Hello everyone and welcome to altogether a new discussion after completing all those methods, equations. Now we are coming to the other important aspect of groundwater engineering, that is geological formations as aquifers. So we in this there will be series of discussions on geologic formations because there are different types of geologic formation, rocks and other things are there. So this is first part. We will see how we will deal with the geologic formations. So let us start, and as you know that groundwater occurs in different geologic settings. Earlier also I have shown a map and also shown through the values that what, say if I give the example of India, that what kind of varied lithology or geological settings we are having within our country. So we are like in Indo-Gangetic plain, we are having alluvial plain, and we may be having in some parts limestone terrain. In some parts of Himalaya also we are having limestone. Then we are having fracture granite, hard rock terrain. We know that each geologic setting is a specific geologic, or I would say unique geological setting. No geological settings of two different areas are same if these areas are located at far distance. So each area, that means each area is having unique geological settings, and therefore before we go for any understanding further about aquifer characteristics, we must understand the geological settings, and then only we would be able to reliably or we can rely on the groundwater for longer time. So, but that understanding is very much required, and because these hydrologic conditions, characteristics of an aquifer definitely depend on the geologic formations. So, it is very important to study and understand hydrogeologic systems which are prevailing in an area which is under study, and also examine the relationships between geology and water as is flowing through it, because water has to flow not only on surface in case of simple hydrology, but in groundwater hydrology it has to flow through aquifers or rocks within the earth, and that understanding is very much required. You recall in the very initial stages of discussions in this course, we have also discussed like hydrologic cycle. So now we are having a rock cycle. Just to understand the geologic formations or geologic characteristics for an aquifer, we should also understand what is rock cycle, like we have understood the hydrologic cycle. You can start say with the volcanic rocks. So when volcanic rocks, when volcanoes are erupted, the magma is coming from the bottom, going up to top, and then flowing on the surface like this. There will be some gases and smoke and other things will come out that will go in the atmosphere. Now there will be weathering and erosion, then the rock particles or grains will form a sedimentary layers like here, and then so you are having weathering and erosion here because of your input which is coming from your hydrologic cycle, that means the clouds, rains, or precipitation, and then it is transported and deposited under maybe on surface, maybe in water conditions. So that becomes our sediments. Now these sedimentary rocks later on may go to some metamorphism or transformations, and goes through the compaction and then cementation also. So they become strong, and then these sedimentary rocks further may go to buried deep underground, and then in those conditions there will be high pressure and temperature, and these rocks will get converted to metamorphic rocks. Now under these conditions again they can get converted to they can melt and can become magma. Again that magma will come on the surface. So this is how rock cycle works, the same way as in case of hydrologic cycle, where precipitation occurs, it goes on the surface, then in subsurface, then it appears in the rivers, and then finally end up in the sea. From sea again there is evaporation, or from trees which are intercepting the rain, they do the evapotranspiration and then again it goes back to the atmosphere. So here this rock cycle continues. It has been continuing since the origin of the earth, that is about 4.6 billion years ago. So the now in a very basic way we can understand this. I am sure must have been told in the initial studies of science. If I remember, it was a few years back, I know that it was in the 10th class or 9th class books of CBSE about the types of rocks. But just to refresh your memory, I will very quickly discuss 3 basic different types of rocks. One is the igneous rocks, then another one is the sedimentary rocks, and third one is the metamorphic rocks. I have also shown through these 3 rocks and through a rock cycle also. So these if I take first the igneous rocks, which are formations through solidification of magma on lava when it comes on the surface. And the example, when we have been discussing different types of aquifers in India, we discussed about basaltic terrain or Deccan traps of India, which covers a large part of Maharashtra, Gujarat and some parts of Madhya Pradesh also, and also in the coastal areas. So this is through the solidification of magma and lava, and that makes our basaltic rocks. Characteristics, they are hard, but normally they will not have layers, but individual flows will be there. So they are not called as bedding plains, but they are called flows. And also I can share that some geologists have identified about 40 flows of Deccan basalt in India. So there were successive flows, and either through typical volcano, which has not been identified in case of Deccan trap, it was fissures. Through fissures the magma was coming, and then there might be some intrusive rocks also, and which may cool down slowly in under pressure and temperature conditions slowly, and they can become like rocks like granite or diorite. These are the large grain rocks, will not have any bending or other things. Like if I give the example of granite, it will have mainly quartz, feldspar, and some mica also it may have. But these generally these grains are large, and nowadays these granites are also using extensively for building materials. Now there may be a middle rock in that sense, not as large grains, so they will be gabbro. Then there are different types of rocks which are called extrusive rocks. So you can have pumice, you can have obsidian, you will have both basalt. Now these are very, very fine grained rocks. Pumice will have lot of vesicles or pore spaces which are empty. When the magma came on surface, the gas escaped, but they left the pore spaces. Obsidian like a glass, and it is just once the magma came and in the sea conditions or in low temperature conditions, it immediately solidified. So no grains, and the basalt which I have been mentioning also. Similarly, in case of sedimentary rocks, the formation through the compaction of sediments. So they will come layer by layer, and the characteristics is the distinctly layer and easy to crumble. That means these can break. The clastic, that is the compaction of broken rocks are there. That means there may be towards the formation of sedimentary rocks, the weathering and erosion processes, these igneous rocks and metamorphic rocks after weathering and erosion can produce sedimentary rocks. So it is not necessary that sedimentary rocks are originated only from igneous rocks, but these materials are the broken materials either from igneous rocks or metamorphic rocks, or even in some cases sedimentary rocks too. So the very famous sedimentary rocks are sandstone, maybe conglomerate, which are having big boulders or pebbles, and then there are a chemical composition which are dissolved material. So like iron ore, you can have a rock salt is there. This is again consumed in our households. not common salt but rock salt, and then coal is also there, though coal is the organic, and so this is organics origin, that means plants or whatever animals were there, mainly it is from plants. So, there is coal, and then of course, the limestone also there. So, these are all main sedimentary rocks. There will be many other sedimentary rocks, but we are not discussing all types of sedimentary rocks or all types of all rocks, but just the major one which concerns us from groundwater engineering point of view. And then the last one comes the metamorphic rocks, and through the transformation of already existing rocks, may be sedimentary or may be igneous. So, these rocks are then transformed through the metamorphic processes, which you require temperature, high temperature and pressure beneath the surface or in the earth itself, and these may have or may not have layers, and compared to what sedimentary rocks are having distinct layers, may have or may not have. So, here the layers we will call as foliations, and that is the distinguished by the layers, and generally the foliation is a very thin compared to our beds or layers which we see in sedimentary rocks. And very good example of these foliated metamorphic rocks is slate, which is also used in hilly areas as building material for covering roof, or in our childhood we have also used these slates to write on this. So, these are the slates which are this simple foliated layers are there. Then you are having gneisses which has got the origin of igneous rocks, that is like granite. So, granite when it is metamorphosed can become gneisses also. Then we are having a flight which is having again a sedimentary origin, but metamorphosed. Then non-foliated rocks you can have which will not have distinguishable layers, that is the marble, again very common material which is used for building and decoration purposes or for making statues and other things. Relatively it is not that hard, and of course, it reacts with the acids and other things, and deteriorate with the time because of a lot of chemicals which are present in the atmosphere. Another very hard rock which is quartzite, and this might be having origin from the sandstone, and then hornfels are also there that we consider here. You have to mainly remember first three types of basic rocks: igneous, sedimentary and metamorphic, and some variety of rocks. Granitic examples I have been given, or in future also discussion I would be given. Large part of India is being occupied by hard rocks which are having granites and gneisses and quartzites and other rocks are there, sandstones are also there. Then a significant part of India is being occupied by basalt, which we call as Deccan trap, and some parts are having different rocks. So, when we say crystalline rocks, we are saying igneous rocks as well as fractured crystalline, then we are also saying metamorphic rocks and sedimentary terrain. And overall we are also having alluvium. Large part of India which is Indo-Gangetic plain is full of alluvium, and some valley fill alluviums are also there which are good for finding groundwater. Anyway, so the many types of geologic formations can serve as aquifers depending on the situation or conditions in subsurface. Some can become confined aquifers, some can become unconfined aquifers. So, as we know that almost all rocks contain some porosity and therefore contain groundwater, but whether there is a permeability or not, that is important. Some rocks may have high porosity, but may not have good permeability, and therefore the flow through these rocks becomes impossible. Anyway, that we will also have a discussion on this. So, our key requirement is from groundwater engineering point of view about these geologic formation is that these rocks should be able to store water in the rock pores or fractures or whatever the gaps which are there within these rocks. Now, porosity is derived from intragranular spaces, and which form or maybe from fracture. So, hard rock, crystalline rocks, they may not have porosity, but because of these fractures we may have these rocks may have the capacity or ability to store water. So, we are looking for water, we do not bother whether the water is in the pore spaces or in the fracture zones. So, large pore spaces means there is less friction between flowing water and the slide or the sides of pores, but this is preferable, but whether we will get or not, that is important. Whereas a small pore spaces, you know that the friction would be more along pore walls and but also twist and turns for water to have to flow through. Once we have discussed while discussing these equations that in the geologic formations, it is not necessary that flow through these rocks will have a smooth sailing or a smooth flow. There will be large openings, there will be smaller openings, and therefore, in those conditions if pumping is done at a very high rate, then there itself it can become the turbulent flow. Anyway, now you know, like materials, sedimentary materials like clay or basalt, which is of course igneous, a unit may have high porosity. Why basalt? Because basalt has got the vesicles. Sometimes these vesicles are filled by the secondary minerals, maybe quartz, calcite and other minerals, amethyst, quartz and other things, but sometimes these vesicles are not filled. So, when the lava came on surface, whatever the gases it was carrying has escaped, now you are having just pore spaces left. So, these pore spaces, if there is some connection, can become useful for or can serve as a good aquifer. So, high porosity, these rocks like clay and basalt. Clay will have lot of porosity, but let me tell you here itself, the permeability is very poor. That means it does not allow water to flow through it very easily as compared to sedimentary rocks or other rocks. So, hence it can hold good amount of water. So, it can store the water, sufficient amount or good amount of water, but pores are too small or sometimes not connected, and therefore, the permeability will be low and well yields will not be sufficient, and that is the challenge which we face in India in this Deccan Trap terrain where basaltic rocks are there. The porosity is high, but permeability is low and poor, I would say. So, now opposite to this, contrary to this, the fractured and weather granite, though they are very hard rocks, hard igneous rocks we have discussed, and may have an high permeability because of fracture and other things, but the porosity is low. So, wherever the openings are there because of fracture, you may have water, but otherwise the rock itself will not have any porosity. And a well will quickly drain the fractures and will not yield much water in long term or long run. This is the problem in all hard rock terrains which occupy a very large area of India. Where hard rocks are there, they are fractures, but you cannot run pumping or you cannot withdraw water from for long time from a well which is having in these rock formations. Because there is no porosity or porosity is very low, you are having the storage of water only in fractures. So, once you start withdrawing water, whatever the water in fractures will come out and then you may not get water from the well. So, it will not have a good yield for regular intervals. So, you have to give time, or otherwise if there is a recharge available, then it is fine. Now, we will see the variations in porosity in unconsolidated materials, and unconsolidated materials we have discussed like alluvium and other things, and then we will see that how these the variations are there in unconsolidated materials compared to our solid rocks. So, here what we are considering the sedimentary rocks and unconsolidated sediments. So, we are considering typical sandstone, conglomerate, mudstone, etc. with the alluvium which is located in the Indo-Gangetic plain like situation. So, this is a comparison between sedimentary rocks and unconsolidated rocks, and sediments over 75% of continent crust with an average thickness of few hundred meters is there. But this is for the entire globe, but we are not we are considering, if we consider in India, then we are having some sedimentary aquifers in our country also, sufficient amount I would say, or not, I would not say sufficient, but a large part of India is also having sedimentary aquifers as well. Anyway, so now we are having we compare with the porosity percentage, which is in percentage. So, these are the intrusive and metamorphic rocks. They are showing good porosity like volcanic rocks. I have already discussed the basaltic one. And then we are having limestones, which are having openings or cavities, and cavernous openings are there. And there is some limestones which are completely solid. If they do not have openings, then they will have porosity of about 20%. Mudstone may have relatively better porosity as compared to limestone. Sandstone is almost same. We are discussing porosity. So, here let me give you the insight about this. The mudstone will have high porosity, but low permeability. A sandstone will have good porosity and as well as can have good permeability also. And of course, the conglomerate will have a high porosity and high permeability. Then glacial till is also there, the sedimentary materials which comes out of glacier and gets deposited in certain conditions. Because it is poorly sorted sediment, so you would have a less porosity, and it is expected that you would also have relatively less permeability as well. Now, there are silt and clay. Clay we have already touched that it will have a very high porosity, but very low. It is it can serve not as aquifer at all. Anyway, but it can be impervious like aquitard, and that can make our aquifers confined and so on. Then we are having sand and gravel. Sand is of course having quite good permeability, 50% is quite high, and then we are having gravel 40% permeability. So, here it is likely to have about around 20% of porosity on an average if we take average of all these rocks, and it is early to see that a huge volume of water can be stored in the ground, but whether we are storing in the ground, that is important. Anyway, that we will see also. So, now based on the geologic origin of aquifers, which are the rocks which are making or forming our aquifers, will based on the type of porosity and rock type. So, here again we are having all these three rock types, igneous and metamorphic rocks all together. Then we are having sedimentary rocks, and we have igneous rocks, as volcanic rocks we have kept as a separate. Now, in in sedimentary rocks we are having three categories: consolidated, unconsolidated, and carbonates means limestone, marble and other things. Here in volcanics, consolidated and unconsolidated rocks, and of course, this is for the metamorphic rocks. So, we will take one by one as per their characteristics. When we see this type of porosity which is irregular, so in case of sedimentary unconsolidated rocks like gravelly sand, clay and sandy clay, they will have irregular porosity. Whereas in consolidated rocks, irregular and fractured porosity, we may have breccia, conglomerate and slate. Now, our carbonate rocks can also have irregular and fractured porosity, and rocks are given here. Dolomite, very famous rocks are there, oolitic and other rocks are also mentioned. Then in case of igneous rocks or igneous and metamorphic rocks, what we are talking only about the weathered zone of granitic gneiss, where we will have irregular porosity, not regular porosity. And fractures, of course, that is the main source of, or that is the main storage of water which can be withdrawn. So, that is the fracture granite, gneiss, metamorphic rocks, gabbro, quartzite, diorite, schist, mica schist. So, some of these are quartzite like metamorphic rocks, these are metamorphic rocks and so on. So, these rocks are though in characteristics they are solid, hard rock we consider them or we classify as hard rocks, but they may have fractures and some having also weathered zone and which will allow water to store, and of course the water can flow also through. If these fractures are connected, then water can flow through it also. So, that the main hope here in case of hard rocks like igneous and metamorphic is the fracture and weathered zone. Now, in case of volcanic rocks, we are having again two categories, consolidated and unconsolidated rocks. Means consolidated here the solid and unconsolidated not that solid. So, what we are having weathered zone of basalt and top part because of exposure to the atmosphere and rain and other things, temperature and cold and other things. So, the top parts get weathered, that can become our storage of groundwater. But this zone is irregular, we do not have regular storage possibilities like in sandstone. And a irregular and fractured part is also there in way which may have volcanic tuffs, cinder. These are all volcanic rocks, volcanic breccia, pumice is also volcanic rock, very high porosity, but may not have very good permeability, basalt, andesite and rhyolite. Let me give you just a general knowledge thing about pumice. Pumice is used in India at least, or I know that it is used in to scrub our skin, and because it is a very light rock and it is quite rough in that sense. So, because of large pore spaces which where the gases has escaped and it becomes very light. So, it is used in our fresh rooms or in bathrooms to rub our skin. Also, if you put this rock in water, it floats, and there are a lot of mythologies are associated with this, which I am not going to discuss, but just to tell you that pumice is a very light weighted rock because large pore spaces are there. Though interconnections is not there, otherwise it will not float, it will fill with the water. So, another type of volcanic unconsolidated rock are the volcanic ejecta, blocks and fragments ash. Sometimes we also get as ash as a geologic formation. So, there the the porosity would be very irregular in all these. So, the top part where we are getting in this one, the porosity is irregular. In the middle part we are getting the porosity is irregular and fractured, and the bottom part if I am getting is fractured and so on and so forth. Now, after the porosity, the second most important thing from groundwater aquifers point of view or rock formations point of view, from geological groundwater engineering point of view, are this the permeability. Because as mentioned few times that there may be high porosity, but if permeability is not there or equally high, then it becomes no use basically. So, permeability is important variable in groundwater engineering. So, variations in hydraulic conductivity in meters per second of unconsolidated materials which are shown in the red in the bottom part here, and rocks which are shown in the blue part at the top. So, we will again here on x axis we are having hydraulic conductivity which is meter per second. So, now this we take limestone with solution openings because it reacts with water, and there are lot of openings or caves or cavities may be there with limestone. So, when this situation is there, we will have a very high hydraulic conductivity which is coming 10 meter per second, which is very high. If you just compare with the other materials, then you would find that it is showing very high, whereas in case of like clay which is showing 10 to power minus 8, which is very less in that sense. So, here then you are having fractured rocks, they too are having relatively high hydraulic conductivity. Then fractured igneous rocks are there, metamorphic rocks, large part of India remember are occupied by fractured volcanic rocks, fractured igneous and metamorphic rocks, limestone, sandstones, these are all solid rocks. Then mudstones will have a low hydraulic conductivity, unfractured igneous and metamorphic, very solid unfractured and unweathered igneous and metamorphic rocks will have further low hydraulic conductivity. And whereas you can see in the among the unconsolidated materials which we are getting in endoganctic plain or in valley fills and other things, the gravels is having the highest here. So it is coming 1 meter per second, and then glacial till, sand and other materials are also there, which shows variations in the hydraulic conductivity because of in not having interconnections of the pores or openings. So limestone in this case or gravel in the unconsolidated materials are having highest conductivity, hydraulic conductivity, and whereas a clay and mudstone, a mudstone in solid rocks, clay in the unconsolidated materials are having very low, relatively very low hydraulic conductivity. Now, as we know that permeability which we are looking here, which is hydraulic conductivity is derivative from that, which we have also seen that it is the permeability which means that it allows the water to flow through the rock formations. Either these rocks can be unconsolidated sediments or how easy it will, how best we can extract the water from it. Storage is one thing, whether the flow is allowed and can we withdraw water from these storage. That is our important consideration here. Now, the materials which are having permeability or good permeability we call as permeable material has a greater number of larger well connected pore spaces, and whereas impermeable, when we say impermeable material, has the fewer smaller pores that are poorly connected. So, for in case of confined aquifer conditions we need both type of materials, one is highly permeable, another one is impermeable, which will make our confined aquifers. So, this characteristics of permeability of a geologic material is basically depend on its origin and will be qualified by geoscientists and engineers using a number of different units, but the most common is the hydraulic conductivity, which on right figure which we are seeing, which is denoted as K also, and can be expressed in meter per second. So, this will give the idea about the basically permeability, and we get the unit also meter per second. In case of unconsolidated materials are generally more permeable because they have not compacted, got compaction, and there no cementation has taken place, and these rocks will compare to like sand, loose sand or other sandstone, and these rocks unconsolidated material may have the coarse materials like gravels which we are seeing here, have very high permeability as compared to the finer one. But it depends on the sorting of these unconsolidated material. Sorting means if I get a sample whether most of the grains are having the same size, then we say highly sorted material, and sometimes we get material like in case of this till and other thing, glacial till and other things, where the materials is poorly sorted, and therefore there you would find large grains and small grains together, and then porosity reduces, permeability is also reduced. But if it is very well sorted material, then there will be gaps between two grains, and then that the gap can become storage, and if these gaps are connected then can become high permeability or hydraulic conductivity. Now, the less permeable or least permeable rocks are unfractured intrusive igneous and metamorphic rocks. Now, in these types of rocks which are completely unfractured, solid, completely solid, are having real challenge from groundwater perspective point of view. So, whether these are unfractured rocks or igneous intrusive rocks that these rocks have formed under subsurface conditions. These rocks have, because of erosional weathering and erosional activities, these have come on the surface or tectonic activities, but initially they were formed underground conditions. Whereas extrusive rocks, when we say igneous extrusive rocks, they have been formed on the surface. When lava came on surface, they formed. When lava did not come on surface, did not appear on surface, laterally it moved and solidified, cooled down slowly, crystals were developed, grains were large, and that becomes our intrusive rocks. So generally these rocks are solid, unfractured, and unfractured are also like sedimentary rocks like mudstone, sandstone and limestone can be unfractured. And from groundwater point of view, these are real challenging rocks for us. So the permeability, if I take of the sandstone, now it depends, can vary widely depending on the degree of sorting which we have just discussed a few seconds ago, that how well sorted sediments are. A poorly sorted sediments will not support high hydraulic conductivity or high permeability. So that is another important thing here, and the amount of cement that is present, the grains, how grains are connected with natural cement. It is not artificial or man-made generated cement. And this cement is because of different minerals. After compaction, these rocks, even sandstones, become solid. Whereas the igneous and metamorphic rocks, which are fractured, and especially fractured volcanic rocks, can be highly permeable. And that is why in some places, even in Deccan Trap, which are having volcanic origin, basalt rocks which are having volcanic origin are highly permeable, because vesicles are already there. So if these vesicles are connected or these rocks are fractured, then we will have high permeability. Porosity was already high, permeability is also high. So these can give us good aquifers. So can, like limestone that has been dissolved along the fractures and bending planes to create solution opening. Now it is said in groundwater engineering that doing all kinds of investigations, pumping test, recovery test and everything in limestone terrain, it is always very, very challenging. Suddenly there might be a cave opening and so on, and the flow, because like Darcy-La says that the flow should be laminar, and then in such conditions sudden openings are there, the flow can never remain laminar, and therefore in limestone terrain, though you may have lot of water, but all kinds of estimations becomes very, very difficult, sometimes really impossible to predict how much water can be withdrawn from limestone terrain if there are dissolutions or openings because of solution activities and so on. And even if they are also having fractures, things becomes very, very complicated. This figure already I discussed, but anyway for the completeness of this discussion, I am again bringing this figure which is showing the major aquifers of Indian subcontinent. So you are having again IGB, that is Indo-Gangetic Basin aquifers, these are shown here, and then you are having a large part of India which is shown in blue color, which is Indian cratonic, volcanic and crystalline aquifers, which are a very large part of India. You are also having unconsolidated aquifers and semi other aquifers are there, and basaltic rocks are also there, like here you are having semi unconsolidated aquifers in this part of the country, and of course the Himalayan terrain having mostly the crystalline aquifers which are there. In some northeast also you are having semi unconsolidated aquifers, and some surrounding countries are also shown, because remember water does not know the political boundaries. So therefore in order to assess the quantity of water available in political boundary area, it is also important to know the geological setup of neighboring countries as well. That is why here neighboring countries information is also given, including the information about Nepal and Pakistan. So these are the major aquifers in Indian subcontinent. So in the surroundings which we are having, and you can, as we have been discussing, you can see that the two major parts are there. One is the IGB, that is Indo-Gangetic Basin or Indo-Gangetic Plain, and second is the Indian cratonic, which is having igneous and metamorphic rocks, and these are real challenging. The only source or only expectation of water because of fracture zones or weather zone in these crystalline rocks. Anyway, now last in this discussion we will see that rivers are source of water. Some are the perennial rivers and there are thousands and thousands of ephemeral rivers, that means the seasonal rivers. In this particular map only major perennial rivers are shown and how their distributions about the recharge rates which are shown here. So, when we see the unconsolidated aquifers again occupying a large part of Indo-Gangetic plain, some parts of deserts. So, very high recharge is possible, but in desert parts we do not get much rain. So, that is a basically challenge from that point of view. Rainfall is less, but these formations are very suitable for high groundwater recharge. And if we come to the other rock types like medium recharge which are having and high recharge is also having a millimeter per year. So, here it is important that these perennial rivers can also recharge. They can be affluent rivers, they can also recharge our aquifers, and it is happening also. And further the recharge rates vary as per the geologic formations, and recharge is dependent on rainfall also. And we know that rainfall is not uniformly distributed all over this subcontinent, and especially I am talking about India. So, the areas which are having large recharge capacity do not receive a relatively high rainfall as compared to areas which are having a relatively poor recharge capacity receive sufficient amount of rainfall. Whatever is the situation, because geologic conditions we can't change. This is a natural made rocks or conditions are there, formations are there. But what we can change, this is important, what we can change to change our storage of groundwater, and all efforts should be made especially in the monsoon time, so that our aquifers gets recharged. And if we are able to hold the water for long time or delay the surface runoff, definitely our aquifers will get recharged. And if these are unconfined aquifers, it is much easier, and at least we will have water. May not be in hard rock terrain, may not be in our wells for 12 months, maybe 11 months or 10 months. So, that is the best way. We cannot increase the rain, we cannot change the geologic condition, but what we can change is the storage of water in subsurface conditions, and that is only possible through understanding of recharge rates of different rock formations and how to recharge by putting check dams or some other groundwater recharge structures by which we can augment our groundwater resources, and that would be a real success story of groundwater engineering. So, with this I end this discussion. Thank you very much.